Today, let's talk more about the leveled regular annuity. We have already solved this question in the past. The question says that if I put $100 into the bank at the end of every year for 5 years, how much is it worth today with a 5% interest rate? The present value of this set of cash flow is 432.9477. We calculate this number by summing the present value of the $100 at the end of each year for 5 years. As you can see, it's 55.2381 plus 90.7030 plus 86.3838 plus 82.2702 plus 78.3525. That equals to 432.9477. But this method is really tedious. If we get 20 years of cash flow, it's not possible to do manually. Therefore, we want to find a closed form expression for this calculation. Let's start with the present value expression. We want to replace the 95.2381 with the original expression. So we copy this here and then paste it here. Next, we'll replace the 90.7030 with 100 divided by 1 plus the 5% to the power of 2. And then we'll replace 86.3838 with 100 divided by 1 plus 5% to the power of 3. And then we'll replace the 82.2702 with 100 divided by 1 plus 5% to the power of 4. And then we will replace the 78.3526 with 100 divided by 1 plus 5% to the power of 5. Next, we'll create a new expression by multiplying both sides by 1 plus 5%. And this is what we got. When you multiply this 1 plus 5% inside the bracket, you will see that some factor will cancel out. So we are going to rewrite this expression by deleting this. And this, because 1 plus 5% in the denominator cancel out, you get 100. And this become 1. And this become 2. And this become 3, and this become 4. Let's compare the new expression with the original expression. You will notice that if you find the difference of these two expressions, some term can be cancelled out. For example, 100 divided by 1 plus 5% to the power 1 to 100 divided by 1 plus 5% to the power 4 can be cancelled out with the same expression here. Therefore, we notice that this expression can be simplified. On the left, we are left with 100 subtract 100 divided by 1 plus 5% to the power of 5. On the right, we are left with 1 plus 5% multiplied by 432.9477 minus 432.9477. On the left hand side, if you factorize 100, you are going to get 100 multiplied by 1 minus 1 over 1 plus 0.05 to the power of 5. On the right hand side, if you expand the first term, you are going to get 432.9477 plus 0.05 times 432.9477 subtract 432.9477. You notice that 432.9477 can be cancelled out. Therefore, you can see that the 432.9477, the present value of the annuity, can be expressed as 100 multiplied by 1 minus 1 over 1 plus 5% to the power of 5 divided by 5%. So I put this inside bracket is because that this has a meaning. In finance terminology, this thing here is called the present value annuity factor. It's just a number, and this number is readily searchable in the present value annuity factor table. From what we have calculated, we can generalize this expression with this formula. It's the present value equals to C divided by interest rate multiplied by the difference of 1 minus 1 over 1 plus r to the power of n. And you can see that this formula is way easier than what we have done before. Finding the sum of the present value of each year's cash flow, it would be an impossible task if you have 100 years without the help of a computer. But with this formula, it would be easily doable. That's it for today. Thank you.